Hey guys, this is your last section of notes for Unit 1B. This is also the last notes page for stoichiometry. So we are doing this the same day in class that we're doing the Stoic Part 2, so make sure that you stay caught up for your exam. So we talked about doing stoichiometry, just converting one element. Now we need to talk about what that looks like in a reaction. So this chemical reaction means that I have 1 mole of iron and it reacts with 1 mole of sulfur to form 1 molecule, or forming the unit of iron 2 sulfide. So those ones, my coefficient tells me that's how many moles of that element that I have. So if I have 10 grams of iron, how many grams of sulfur do I need? So I'm going to flip to my notes kind of back and forth here so that I can draw what this is going to look like. So give me 1 second. Okay, let me open up my notes so I know what I'm looking at. Just a second. Okay, so I have, oops. All right, in black. So I have Fe plus S, and that gives me FeS. So my problem says I have 10 grams of iron. So to do these problems, I want you to write what they give you in the equation above that element. So I have 10 grams of iron, and it's asking for grams of sulfur. So over sulfur, I'm just gonna write X gram question mark, because that's what I'm trying to find. The next thing I want you to do, if I have grams up here, my same unit needs to go below. So anytime I have grams, that tells me I'm gonna go to my periodic table and I'm gonna find the molar mass of those elements, okay? So hold on, I don't have a periodic table sitting in front of me. So I'm looking for the mass of iron, and that is just 55.845, and then I need the mass of sulfur. I'm gonna plug that in. That is 32.065, and now I have a proportion, okay? So I have 10 grams over, over 55, goodness, 55.845, and then I have X over 32.065. All I have to do at this point is just cross multiply and divide. So I'll give you a second, put that in your calculator while I do it on this side. So I have 10 times 32.065, and then I'm gonna divide by 55.845. And I got 5.74. So that's how many grams of sulfur that I need in this question. Okay, let's move on. To solve these types of problems, it's easiest to write what you know above the actual equation. That's what I just showed you. Let's do another example. Carbon dioxide can be commercially prepared by heating chalk or calcium carbonate. How many moles of CO2 can be produced when I have 3.05 moles of calcium carbonate and I'm heating them? So first step is to write your equation. I did that for you. I won't always do that on the test, so make sure you know how to write these equations. I knew that this was decomposition because it only gave me one reactant, and it says it was being heated, so that gives me a hint that it was decomposition. So again, I'm gonna do the same thing here and go back here. Okay, so I'm gonna write out my equation on this. I'm gonna have to go back and forth a little bit here. CaCO3, so CaCO3, and then I get CaO plus CO2. So it says that I have 3.05 moles of calcium carbonate. So I'm gonna change colors. 3.05 moles of this. So again, I'm starting with moles on the top. I'm just gonna bring my unit down. So I'll say mole, and then I'm looking for, let's see, how many moles of CO2. So above CO2, I'm gonna write just X mole, question mark, because that's what I'm looking for. So again, I'll have moles down here. So now anytime I have moles, I'm just gonna look at the coefficient. This is already balanced for us, and the coefficients are just 1 because there's nothing there. So I can say 1, 1. Now my proportion looks like this. So if I cross multiplied and divide, I would just get 3.05. So that's my answer. That's all you have to do. You're just cross multiplying and dividing. Okay. Let's look at another example. Group 1 metals are explosive when they come into contact with water. If 20 grams of potassium were to explode with excess water, how many moles of hydrogen would be produced? So step 1, write out your equation. I already did that for you. Now I'm gonna go back here and write that down. So I have 2K plus 2H2O. And that gives me 2KOH and 1H2. Okay. So it says I have 20 grams of potassium. I'm trying to find moles of hydrogen. So 20 grams here, I'm looking for moles of hydrogen, so I can put that there. So again, whatever unit's on the top, you need to bring that unit down. So I'm gonna have grams here, and I'm gonna have moles here. Well, right away, I can go ahead and put a 1 under that mole because there's not a coefficient, so I assume that there's a 1. Potassium, I need to look up my mass from the periodic table. The mass of potassium is 39.0983, but I have 2 of them, so I need to multiply by 2. So my mass would be 78.196, about that. I have my proportion, or my equation, so I can set it up just like this. X over 1. So all I need to do, 20 times 1, so that's 20, and then divide it by 78.196. That means X is 0.2557, and that's in moles. So that would be my answer. Okay. Sometimes you're going to have to find the limiting reactant first, so that gives me one extra step that I need to do. Here's my example. Cigarette lighters use butane, C4H10, as their fuel. If 120 grams of butane burn with only 55 liters of O2 at STP, standard temperature and pressure, how many liters of CO2 are produced? Which reactant is your limiting reactant? So the limiting reactant is just the one that runs out first. So when I try to solve for it, it's going to be my smaller number. So here's my equation. That's my first step. Okay. First, I need to find my limiting reactant. So to do that, I'm going to do exactly what I was doing before. I'm going to write what I know from the equation on my, or what I know from the example on my equation. So 120 grams, that was given to me in the problem. Since that was grams, I went ahead and found the mass of 2C4H10. Remember that 2 goes to the C and the H. So I have 8 carbon and I have 20 hydrogen. That's how I got that mass. And then I have 55 liters of O2, oxygen. So remember when we're talking about liters, we use that 22.4 liters. So I just multiplied 22.4 times 13. And that gave me 291.2. Okay, so that's my first step. Divide each proportion to find the smallest number. This will give you the limiting reactant. So 120 over 116.248, that came from my problem on the last slide. That gives me 1.03. I'm going to do the same thing with oxygen. 55 divided by 291.2. That gives me 0.188. So oxygen is smaller. That makes it the limiting reactant. Next, I'm going to use my limiting reactant to solve the rest of the problem. So here's my problem again. Here's my equation. Now I'm going to write what I know again on the top of the equation and cross multiply and divide. Okay, so I'll write that over here. I'm only going to write down the oxygen part because I won't use butane. So I'll say 1302. Let's see. And I'm also talking about carbon dioxide, so I'm just going to put that part plus 8CO2. Of course, you can write out that whole entire equation. I just didn't this time. I'm kind of doing a shortcut. So for oxygen, I had 55 liters, so I can write that on the top. So I'm only using oxygen in this problem because it's my limiting reactant. I don't care about butane because it was not limiting. It was in excess. So now I need to do, again, that 55 times 22.4. That gives me that many liters. Oops, I'm sorry. I multiplied the wrong thing. You should be doing 13 times 22.4. So that's 291.2 liters. And then it wants me to find liters of CO2. So I'm going to say X liter question mark. Right here is my coefficient. I need to multiply that by 22.4 when we're talking about liters. And that gives me 179.2 liters. So I have enough for my proportion. Go ahead and set it up. You don't have to rewrite it every time if you don't want to. I'm just doing that for now. Okay, so 55 times 179.2, and then divide that by 291.2. That gave me 33.84, and that would be liters of CO2. So I'm just solving for X. Okay. One final note. Some of the problems will require you to convert something called molarity. Molarity is how we measure the concentration of an aqueous substance, a substance that's dissolved in water. Since it isn't a solid, we can't really measure it in grams. Many substances in chemistry are dissolved in water because it's easier to use. It's defined as the number of moles of a substance dissolved in liters of solution, so moles over liters. For example, a 3 molar solution of hydrochloric acid contains 3 moles of HCl dissolved in 1 liter of water solution. What if we wanted to convert 750 milliliters of 3 molar solution into moles? We can use that mole map, but basically you're just multiplying liters by the molarity. So it would look like this: 0.75 times 3 gives me 2.25 moles HCl. I don't think you have any of those practice problems on this paper, and I won't put any of those on the test, but that's just something for you to know. Okay, you should have about 5 practice problems on this page.